My name is Yolandi van Deventer. I am from the Procare branch in Bloemfontein. I'd like to say very welcome to all of you who are attending our training course. I hope you will find it very interesting. With the online, it's sometimes difficult to get questions asked, but you are most welcome to email the questions, or I will give you my cell phone number if there are any issues or any questions that you may have regarding the training. So what we are going to look at today, with the introduction to wound care course, we are going to look at the skin as an organ, and we are going to identify and discuss the different layers of the skin, the functions of the skin. Then we're going to go a little bit more in depth into the wound healing process. We're going to differentiate between acute and chronic wounds. We're going to look at healable, non-healable, and maintenance wounds. We're going to identify factors that influence wound healing. We're going to look at wound infection and differentiate between colonized and critically colonized wounds. Also, we're going to look at different tissue levels of infection. So when we say that the skin is an organ, we usually, if we think about an organ, we think about all our most vital organs, like the heart, the liver. But what we tend to forget is that the skin is the largest and one of the most important organs of the body. And it usually very often gets damaged due to injuries like exposure to nature, sunburn, and chemicals. Mark Twain once said, "The finest clothing made is a person's own skin, but, of course, society demands something more than this." Meaning that due to society demands, we can't go walking around naked like they did in the old days. But actually, our skins are prepared and equipped to maintain function and to protect us. And it is a vital organ. All right, so when we say we have a look at the skin, we say that the adult skin surface is approximately 1.2 to 2 square meters. So roughly, if we can take off our skin and unzip it in some way, we will be able to cover a double bed with the skin that we are having. It comprises about 16 to 17% of our body weight, and under normal circumstances, it receives about 33% of the circulating blood volume, which is quite a lot. It's a third of our blood volume, that's our skins. And then if we look at the pH, it tends to go to 5.5, which is slightly more acidic. So when we look at the structure of the skin, we are going to refer back to this during the training. But when we look at the structure of the skin, there are two main functional components, and that is the cutaneous layer, the epithelium and the connective tissue, and then we get the deeper layers, that is the appendages or additional structures in the cutaneous layers. Like example, your sweat glands, your sebaceous glands, your hair and your nails. And then the cutaneous layer of the skin comprises of the epidermis and then the dermis. We go back to that slide. If you see on the right, the top is the epidermis, and just below the epidermis is the dermis. Below the dermis, you will find the hypodermis. If you can see in this illustration as well, that in the dermis, you will find the sweat glands, the sebaceous glands, all the blood vessels are deeper inside of the skin layers, and that is in the dermis. So underneath or below the dermis, you will find a connective tissue layer, and that is called the hypodermis. And the function of the hypodermis is to support the dermal layer. Okay. So when we break it down and we look at the epidermis, we will see that the epidermis is the outmost layer of the skin. And this is the layer of the skin that is in contact with the external environment. The epidermis is avascular, meaning that it is without blood vessels. It doesn't have any lymphatic network. And very important to remember that the epidermis is dependent on the dermis to receive nutrition because the epidermis is avascular. The thickness is about 0.08 millimeters around the eyes. And then in thicker skin, like in the palms of the hands or the soles of the feet, it can go up to 1.5 to 4 millimeters thick. So the epidermal layer is also broken down into epithelial layers. So if we speak about the epithelium of the epidermis, we mean that it's a paving of cell layers or layers that form the outer border of an organ. And these layers of cells have got certain properties. So if we look at the anatomy of the epidermis, we will see that from the top, if you look at the illustration on the right, we will see dead cells flaking off at the skin surface. And that is the stratum corneum. Below that, we get the stratum lucidum. Lucid means transparent. Below that, stratum granulosum. And then the stratum spinosum. Then the stratum basale. And below the stratum basale, the epidermis starts. So if we look at the basal cell layer, which is the deepest layer of the epidermis, it's a single layer of living cells, and these living cells are on the basal membrane. So the basal layer and the prickle cell layer, the stratum spinosum is also known as the prickle cell layer. They look like little pin cushions if you look at it under a microscope. So the stratum basale and the stratum spinosum, or the prickle cell layer, they are responsible for continuous production of new cells to renew the old epithelium, the desquamate of the skin surface daily. If we speak about desquamate, it means that they dry out and they fluff off. It's like very dry skin flakes that you will see. That's the meaning of the desquamate. It renews about every 28 days. Old cells are then washed off. The basal cell layer contains pigment cells. We call those the melanocytes, and the melanocytes contains melanin that is responsible for skin color. If we get a certain ethnic group, the albinos, they don't have, they have the melanocytes, but the melanocytes are unable to produce melanin. So that is why they don't have any color to their skins. Right. Then on top of the basal cell layer, you get the prickle cell layer, which we also, now let me just go back there, refer to the stratum spinosum. And this prickle cell layer consists of a number of layers of living epithelial cells. And these cells have started the transformation process. Inside, the cytoplasm has shrunk, and this gives them the appearance of tiny pin cushions, like our grandmas used to have. I remember if you bought the pins in a little holder, it had like a foam or a sponge on top, and we used to stick in the pins on there when they were sewing. So this is the ideal picture that you can have of the prickle cell layer. Okay. Then, if we look at the stratum granulosum, or the granular layer, this is where cells begin to flatten. This is the typical image that they will have under a microscope. And they start producing large quantities of cytoplasmic protein. Open sensory nerve endings that are responsible for touch and pressure awareness extend into this layer, and they are found between the epithelial cells. So if you don't have this layer, the horny layer is next. So the lucid layer is usually on top of the granular layer. The lucid layer, or the stratum lucidum, is lucid meaning transparent, like we said. It's a clear layer, it's transparent. So it's present only in hairless skin. Very important to remember, over the palms of the hands or the soles of the feet. And that is where thickness is required in order to gain protection. So the granular layer with the clear layer form a non-permeable barrier that protects the body against transmission of harmful substances. If we look at the horny layer, or the stratum corneum, the most top part, it is also called the horny layer because it's very dry. It consists of multiple layers of dead cells, and that is the uppermost layer of the epidermis. So when new epithelial cells are formed in the basal and prickle cell layers, they are undifferentiated. They don't have any function yet. They're not differentiated into the type of cell that they need to be. So these cells have the ability to differentiate, and as they move through the epidermis to produce keratin, they become known as keratinocytes. So keratin is a fibrous, insoluble protein that strengthens the horny layer. It makes it light, supple, durable, and water resistant. In the case where you have calluses and corns present, keratinized skin areas that contain higher amounts of keratin cause calluses and corns. Then epithelial cells undergo last changes in the horny layer. They flatten, they get filled with keratin filaments, and their cell membranes thicken. And if they have a loss of their cell structures, it results in death. They become dehydrated and pack closely together. The topmost cell layer is loosely packed, it's less adherent, it erodes, and it desquamates daily. So if we mean it desquamates daily, if you take a bath daily and you see that there's a darkish, blackish ring around the inside of your bathtub, that usually is the skin that is desquamating, that is literally falling off, getting loose, separating from you, and that forms the ring around your inside of your bath. Okay, so the horny layer, or the topmost layer, the stratum corneum, protects the underlying layers of cells and tissues. And this doesn't allow passage of microorganisms into the deeper structures. This is also water resistant. Gases and fat-soluble substances penetrate the body to a certain extent. If you look at petroleum jelly like Vaseline and lanolin, they penetrate the skin through the sebaceous glands and the hair follicles, and not through the layers, the epithelium, the epidermis. So it goes another route to penetrate the skin. Normal stratum corneum is very dry, and that is unattractive to microorganisms, and it inhibits colonization. Okay, so when we go back and we just recap quickly, from the top to the bottom, we said it's the stratum corneum, the stratum lucidum, the stratum granulosum, the stratum spinosum, the stratum basal, and then the dermis. So a simple rhyme for you just to remember from the top to the bottom is, if we look at the corneum, just forget about the stratum. Stratum means layer. So if we look at the first letter of each layer, it's C, L, G, S, B. So come, let's get sunburned. Corneum, lucidum, granulosum, spinosum, basal. Come, let's get sunburned. So in thick skin, we will have all 5 layers present. In thin skin, we will have only 4 layers present. We said that the lucid layer is only present in hairless skin. So the lucid layer is the layer that won't be present then. Okay, so if we talk about the next layer that is very important for us to focus on, it is the dermis. So the dermis is the second main layer of the skin. It's also known as the corium. This can also differ in thickness. So in thick skin, it's about 3 millimeters thick. And in thinner skin, it's about 0.5 millimeters thick. The basal membrane joins the epidermis and the dermis, and this is called the dermal epidermal junction. Inside the dermis, you will find blood vessels, lymph, and nerves. Blood supply in the dermis is primarily for the regulation of temperature and blood pressure, secondary for nutrition of the skin. Connective tissue contains large amount of collagen fibers. So collagen we will hear about and speak about later again. Collagen is very, very important in wound healing and in the body as well. So collagen is a fiber, protein fiber, that forms a network that gives the skin tensile strength and elasticity. So if you get older, your collagen decreases and you get wrinkles. And if we speak about tensile strength, it means that we can stretch it without tearing. So our skins are made to stretch. If you look at a piece of material that you buy in the material shop, sometimes they cut a little hole and they tear it. So instead of cutting it, so that tearing means that it has a very low tensile strength. We can't stretch it, it will tear. So in the dermis, you will find the fibroblasts in the layer that forms the fibers. If we refer to a fibroblast, that is a cell that produces collagen. Any cell that ends on a blast, like fibroblast, it means that it produces something. Macrophages are white blood cells, and they have the ability to migrate out of the circulation of the dermis and to move to the matrix. So if we refer to the matrix, it is also known as the ground substance, and it's a gelatin-like intercellular fluid within the tissues. Okay, so the macrophages, which is the white blood cells, penetrate inflamed, damaged, or injured tissue, and their aim is to clear up damaged or dead tissue, infective matter, and toxic substances. So if you have this image in your mind. If you've ever seen that video game Pac-Man, the macrophages are the Pac-Man or Pac-Man of the wound. They come and they boop, 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 and they clear up damaged tissue, infective matter, and toxic substances. Okay. Then the mast cells are also found in the connective tissue of the dermis. And the mast cells, when a wound occurs, they secrete histamine at the start of the inflammatory phase of the wound healing. So the dermis itself is divided into two layers. This is just for interest's sake, the papillary layer and the reticular layer. So if we look at the papillary layer, it's characterized by papilla that extends to between the epidermal ridges. It contains encapsulated sensory nerves of touch and temperature and open nerve endings for pain. Sweat glands, arterioles, and smooth muscles of the skin are involuntarily controlled by the sympathetic nervous system. So the arrector pili is the smooth muscle that contracts and causes goose flesh. The second layer of the dermis is the reticular layer, and reticular means it's like a net. The connective tissue in this layer is very compact, and bundles of collagen fibers in this layer extends into the papillary layer. So these two layers can't be clearly differentiated. Collagen fibers also extend to subcutaneous layers to ensure that the dermis is firmly attached to the rest of the body. Partial thickness burns extend into this layer. So the subcutaneous layer is a layer of loose connective tissue that supports the skin. It attaches to the underlying structures, the muscles, the bones, and the organs. And this also supports the large blood vessels, lymphatic vessels, and the nerves that branches into the dermis. The subcutaneous layer contains large number of fat cells, and fat deposits formed and stored here makes it the thickest layer. So this is totally the deepest layer before you go to the muscle. Thinner layer of the subcutaneous tissue occurs over bony prominences, which makes sense. There's less fat over bony prominences, elbows, scapula, all the bony areas. And this is also where your high risk comes from with regards to pressure injuries, because there's less supportive structures for to support, to protect. And loose connective tissue makes the skin very mobile, especially over joints. So the subcutaneous layer, the tissue and the fatty deposits insulate the body against heat and cold. It protects underlying organs, and full thickness burns, stage 3 pressure injuries, and leg ulcers extend into this layer. So if we speak about the skin and the appendages and the additional structures, we are talking about the integumentary system, and this includes the hair, the nails, and the special glands. So the hair and the nails, we spoke about the keratin cells. It's keratinized appendages of the skin. Nails are hardened plates consisting mainly of keratin and large amounts of sulfur. Sebaceous and sweat glands are present. Sebaceous glands occur all over the body except in the palms and soles. They secrete a waxy lipid and broken down cell material, and microorganisms are expelled in this way. The lipid, also known as sebum, prevents desiccation. Desiccation means drying out of the hair and the skin. It inhibits bacterial growth, and it also acts as a skin conditioner. So the greatest amount of sweat glands are found in the palms, the soles, and the axilla. And the primary function of these sweat glands are to maintain body temperature. If we look at the function of the skin provides protection against microorganisms such as bacteria, fungi and viruses. It protects us against dehydration. It protects us against minor injuries. It protects us against heat and cold, UV irradiation, and also against penetration of and damage by absorption of chemicals. It regulates the body temperature through insulation. This is done via the adipose or fatty tissue and hair, perspiration and evaporation, and vasodilatation and constriction, which is autonomic sympathetic nerve control. Functions of the skin also includes the synthesis of vitamin D, melanin, and keratin. So if you are in the sun, the skin doesn't at all synthesize the vitamin D itself, but the rays of sun on the skin sets the process to start for the vitamin D to be produced by the liver. The next function of the skin is to ensure perception of the environment via sensation of pain, touch, temperature, pressure, and vibration. And all of this contributes to protection. Another function of the skin is nonverbal communication by means of appearance and change of color in the skin, if you are blushing or if you are pale, facial expression, and sensation of touch. And then also maintenance by ensuring skin integrity and initiating wound healing. So when we look at the pH of the skin, like we said, is around about 5.5, which is more acidic, only our normal skin flora flourishes in this acidic environment of the skin, which is also a protective function, a protective barrier function.